Alright, so Unit 2, Day 2. We've got notes over the vertical shifts. So all these parent functions that we were dealing with on Day 1, we can manipulate them all in a very similar manner. Alright, and that includes everything, including our horizontal shifts. Horizontal shifts. And then there's going to be another one that we're going to be doing, and that's going to be reflections. Okay, now today we're focusing in on vertical shifts. Reflections. Alright, now if you'll notice from yesterday, we've added something to all these functions. Okay, there's a little extra to every function that we did yesterday. And if you'll notice, they're all the exact same function that we were using yesterday on Day 1. Okay, we've got our absolute value, we got our quadratic, we've got our square root, we've got our cubic and cube root, and rational functions. Okay, so today to our absolute value function, we're going to go ahead and we're going to add 3. Okay, so we start off with our absolute value function, and we know that looks kind of like this. It goes like that, and this one's gonna go like this. Okay, and it goes like that, and it goes like that. Okay, now that's the original. That's the one from yesterday. Now, this one says that we're gonna move everything up by 3. Okay, that's what that 3 on the end stands for. Okay, and we're gonna go ahead and move every dot 1, 2, 3 up 3. Alright, it goes just like that. Okay, and we're just adjusting that parent function by just a little bit. Okay, so and there it is. There's that, and there's that. Okay, now we're going to do something very similar to our quadratic. Okay, we're going to start off at 0, 0 and graph the original function. Okay, and then over 3 up 9, and then we got this one over 3 up 9, and it's going to go doop, 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 like that. Boom and boom. Okay? Now, our domain for this function, here, let me go ahead and finish up what I'm doing. Okay, so this one says that we are going to move everything up by 1. Alright? Everything up by 1. Right there. And it's going to look like they almost cross in several places, but they never actually cross. It's almost like setting like a cup down inside of another cup. They never actually cross. They just kind of sit one inside of the other. There we go. Okay. And I know that that looks really bad in the middle there, but sorry. Okay. So our domain for this absolute value function, you go back and finish this. So the domain is going to be negative infinity, less than x, less than infinity, right? And the range, if you'll notice, gets cut off right here at 3. It doesn't go any lower than 3. So we incorporate that. That's going to be 3 less than or equal to y less than infinity. The maximum of this function, well, there is no max, but there is a minimum, okay? That's the lowest value that's achievable on that function, okay? Now, the minimum lowest y value that can be achieved happens at 0, 3. And then the x-intercept, well, that just doesn't happen on this one. Okay? Non-applicable. Okay? And there we have it. Okay. Now, for number 2, the domain is going to run from negative infinity to infinity. And the range is going to start at 1 and run all the way up to infinity. The minimum, as we can see right here, it bottoms out at 0, 1. The x-intercept, not a thing on this one. Okay? But we do have a y-intercept that we need to log. Okay? And there we go. Okay, so the y-intercept is going to be 1, 0. Or not 1, 0. Whoopsie, got that backwards. It's going to be at 0, 0, 1. Alright? Okay, so moving along here. This one was 0, 3, by the way. Okay, so moving down on to the next problems. Okay, so let's see. Again, it's always a good idea to go ahead and graph the original. Okay, goes right there, 1, 1, 4, 2, 9, 3. And then we're going to take that and extend it on out. Okay, like that. Now, let's see. This one says that we're going to move it down 1. Okay, we're going to move our function, everything, down 1 unit. There's 1, there's 1, there's 1, there's another one. Okay, and I can go ahead and connect my dots. And it goes like that. Alright, so let's see. What winds up happening? Well, the domain starts at 0, less than or equal to x, less than infinity. The range on this starts at 0 and runs to infinity. Normally, right? That's the original function. Now, this one changed and is altered just a little bit. Okay? Because it actually starts down here at -1. So we got -1 to infinity as far as the range goes. Alright? Now, number 4. Let's see. What's going to happen? Oh, let's go ahead and finish up number 3 with the max and min and everything. Whoopsie. Slightly out of my view. Okay. Okay. So the minimum of this function, as we can see we have a minimum, is going to occur at 0, -1. The x-intercept of this is going to be at 0, +1. As you can see, it crosses right there. And the y-intercept is going to be at 0, -1. And there's that. Alright, now, number 4. Number 4. Okay, we need to do x cubed -1. So we're going to start off by graphing the original function. And it goes like that. Right there, and right there. So it goes down, and then this one's going to come up, pass through the origin, and kind of curve back up towards the top. There we go. Okay, so it kind of goes like that. Alright, and the Now it says that we're going to move this down 1. Everything's going to get moved down 1 point. Okay. So move everything down 1 point. And there's that. Now, let's see. That's going to go like that. Like that. Like that. And on up. There we go. The domain of this is going to be negative infinity to infinity. And then we've got the range, which is going to run from negative infinity to infinity. Okay. The maximum and minimum, well, let's see. If you'll notice, it extends in the downward and upward direction forever. So therefore, the maximum and minimum doesn't exist. At least for the time being. We'll start learning about relative maxes and minimums at a future date. Okay? And then we got x-intercepts. Well, this one crosses the x-axis at 1, 0. And then the y-intercept is y equals negative 1. Okay, and that finishes off the front page. Alright, so on number 5, we've got our cubic root function again, okay? And on this one, we're going to move it down 2, or not down 2, up 2, okay? And let's see, so always a good idea, go ahead and graph our original function. And it goes like this. This is where knowing your parent functions comes into handy. Okay, goes like that, and goes like that. Alright, now it says that we're going to add 2 to every dot. So move each dot up 2 spots. Right there, right there. Let's see. 1, 2, right there. 1, 2, right there. 1, 2, right there. And then we can just go ahead and play connect the dots. Bloop, 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 and bloop. Got them all. Okay, so that easy, okay? There's our new function. Now let's go ahead and draw our conclusions about the domain, the range, and all that stuff off of the new function. So the domain for this function, okay, starts at negative infinity, and that's going to be less than x, which is less than infinity, right? It extends in both directions with no bound. Okay, and the range, as we can see, never stops either. So we can go ahead and say that's negative infinity to infinity. Okay? There is no maximum or minimum to this. Okay? And it's pretty easy to pick out our x-intercept. Okay, even with my horrible graphing skills, I know how to plot a point. Right? So that right there is our x-intercept. It's pretty easy to see. At negative 8. Why do I keep wanting to draw infinity signs? Negative 8, 0. And the y-intercept, as we can see, occurs right there at 0, 2. Alright? Now, time for the last question of the day. We've got our rational function. Okay? And that's going to go a little something like this. If you remember correctly, we're going to have a point here and a point here, and we got to drop our line kind of like that and get really close to our axes, but never actually touch them. And it kind of goes loop, and this one kind of goes, oops, kind of goes out and down to the other end. There we go. Okay, kind of goes like that, and we're gonna get close, but not exactly touch. Okay, so that's the original. Now, it says that we're gonna move it all down 1 unit. Okay, so everything's gonna get moved down 1 unit. Right there. Okay, so what does that mean? Well, it's going to look very, very, very similar. Okay, and I apologize that my graphing, hand drawing my graphs skills are not that great. Okay, but you can tell, hopefully, that those graphs don't actually touch, but they get very, very, very close. And there we have it. Okay, now the domain for this, just like the other one, or like the other rational function from yesterday, is very unique. Okay, it actually has a break in the middle. So our domain is going to start at negative infinity. Okay, and it's going to run all the way up to 0 and then stop. Union, and then it's going to go from 0 to infinity. Alright, now the range, again, it's going to be very similar to yesterday, but not the exact same thing. If you remember yesterday, it broke at 0. Okay, but today, if you notice, our range actually stops here at 1, or at -1 rather. Pardon me. Okay, so that's going to be negative infinity to -1 union -1 to infinity. Okay, our maximum and minimums for this, okay, well, there is no maximum and minimum, so non-applicable. And let's look at the x-intercept, which actually does exist for this. Okay, it's at over 1 up 0. I don't know why I tried to put a -1. There's that. Okay, so we got 1, 0. Okay, and the y-intercept still does not exist. D and E. Okay, so some of y'all are probably going, whoa, 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 wait. Okay, so yesterday we didn't have a x-intercept, and now all of a sudden you wave your hands and something magical happens, and now we have an x-intercept for a rational function. How does that work? Well, we moved it down 1, and since yesterday we got close to the x-axis, if we moved the whole thing down a unit, now we actually hit the x-axis. Okay, so therefore we have an x-intercept. And thanks for watching.